back to KK Mishra's tutorials. We are further going to discuss the projectile motion. Earlier we had derived the expressions for the time of flight t, maximum height h and horizontal range r. But the point of projection A and point of landing B were at the same level. Today we shall discuss the projectile motion when point of projection A and point of landing B are at the different levels. U is the velocity of projection and theta is the angle of projection. We take A as origin and upward direction as positive direction. We resolved velocity of projection U in horizontal component U cos theta and vertical component U sin theta. Now consider the vertical motion. Velocity in the vertical direction at maximum height c is 0. So we have final velocity v equal to 0, initial velocity u equal to u sin theta, acceleration a equal to minus g because g is downward, and distance traveled s equal to h. Using the relation v square equal to u square plus 2as, we get 0 equal to u square sin square theta minus 2gh. That gives us maximum height h equal to u square sin square theta by 2g. So we see that maximum height achieved is still h equal to u square sin square theta by 2g, same as earlier. Let the time taken to reach the maximum height h is t. Using the relation v equal to u plus at, we get 0 equal to u sin theta minus gt. It gives us t equal to u sin theta by g. So time taken to reach the maximum height is also the same, t equal to u sin theta by g. Now let us calculate the time taken by the projectile in reaching from point of projection A to point of landing B. The duration of time in which the projectile remains in air. It is called the time of flight and we represent it by capital T. We shall use the relation s equal to ut plus half at square. Here t equal to capital T and s equal to minus d because the final displacement is in the negative downward direction. U and A has the same value as taken earlier. Now we have minus d equal to u sin theta into t minus half gt square. It gives gt square minus 2u sin theta into t minus 2d equal to 0, which is a quadratic equation. Solving this quadratic equation for t, we get t equal to u sin theta plus minus under root u square sin square theta plus 2gd by g. If we see this expression minutely, we will find that it is in fact a generalized expression for the time of flight. Let us see how. Case 1. When A and B are on the same level. A and B are on the same level. Since level difference is 0, so D is 0. We put D equal to 0 in this expression and get two values of T. 0 and 2u sin theta by g. 0 is for the position A and 2u sin theta by g for the position B. It is same as discussed in earlier part. Case 2. When B is lower than A, we have derived this expression for B lower than A. We are getting two values, but one of them is negative because under root u square sin square theta plus 2gd is greater than u sin theta. Negative time is not acceptable, so we take positive time of flight as below, t equal to u sin theta plus under root u square sin square theta plus 2gd by g. Case 3. When B is above A, here D is positive because it is upward displacement. Since we have derived this expression for taking d negative. So in this case we reverse the sign of d in the expression and get two positive values of t. Here plus minus two values of t. Both are true because there may be two positions of b at d height above a as shown in figure above. This and this. Smaller value of t is for the ascending path while larger value is for the descending path. Let us now separate this expression in two parts as below. The first part is u sin theta by g, which is the time to reach the maximum height, and second part is plus minus under root u square sin square theta minus 2gd by g. It is the time taken to travel from maximum height to point B. If we put d equal to h equal to u square sin square theta by 2g in this expression, means B coincides with maximum height point C. Second part of the expression becomes 0 and we get the time to reach maximum height same as derived before. Let us solve a problem. In a game challenge, there is a pole 66 meters high on which a ball is placed. The player has to hit the ball with a projectile by standing x meter away from the base of the pole. Find the angle of projection of the projectile theta and the distance x if the velocity of projection is 50 meters per second and point of projection is 2 meters above the ground. Projectile released by the player remains in the air for exactly 2 seconds and hits the ball on the pole. First, draw a diagram for this problem, and we have t equal to 2 seconds, u equal to 50 meters per second, d equal to 64 meters. Now put these values in the expression derived. We have 2 equal to 50 sin theta by g plus minus under root 50 square sin square theta minus 2g into 64 by g. We arrange it and square both sides and get the value of sin theta equal to 0.836. It gives theta equal to 57 degree. Horizontal distance travelled x is calculated as u cos theta into t equal to 50 into cos 57 degree into 2 seconds. It gives x equal to 54.5 meters. Now horizontal range when there is level difference between point of projection and point of landing. Since we have calculated the time of flight, horizontal range can be easily calculated by multiplying horizontal component of velocity of projection u cos theta by time of flight t, because horizontal motion is with uniform velocity. So horizontal range r equal to u cos theta into time of flight t. We replace t by this expression and get the value of r. We put d as positive if b is above a, otherwise negative. Hope this discussion is useful in further understanding the projectile motion. Thank you.